Alright, Chapter 4, Hydraulic Actuators. Chapter 4, Hydraulic Actuators. Field Manual 5499, Hydraulics, Hydraulics, Department of Army, Distribution Restriction approved for public release and distribution is unlimited. Alright, Chapter 4, Hydraulic Actuators. Hydraulic actuators receive pressure energy, converts into mechanical force and motion. Actuator can be linear or rotary. Linear actuator give you the force of motion outputs in a straight line. It's more commonly called a cylinder, but it's also referred to as a ram, reciprocating motor, linear motor. Rotary actuator provides torque and rotation motion, more commonly called hydraulic motor or motor. Cylinders. A cylinder is a hydraulic actuator constructed with a piston and plunger that operates with a cylindrical housing action with a liquid under pressure. Figure 4.1 shows the basic parts of the cylinder. Cylinder housing is a tube in which the plunger piston operates ram-type system. Ram actuates the load directly with the piston. Cylinder is a piston rod connected to the piston actuates the load. The end of the cylinder from which the rod plunger produces is the rod end. The opposite end of the head end. The hydraulic connections of the head end port and rod end port fluid supply. Single acting cylinder. The cylinder in Figure 4.1 only has the end port as an operated hydraulic in one direction. The oil pumped into the pump pushes on a plunger that extending out and extending it. To return and retract the cylinder, oil must be released to the reservoir. A plunger returns either because of the weight of the load or from some mechanical force such as a spring. Mobile equipment of flow to and from single-acting cylinder is controlled by a reverse-directing cylinder direction valve with a single-action type. Double action cylinder. Cylinder Figure 4.2 on page 4.2 must have a ports and have head and rod ends. Pumping oil into the head moves the pistons extended with the rod with only an oil in the rod end. Push the oil, return to the reservoir, retract the rod, flows reverse. Oil from the pump goes into the rod end, head end of the port, connected to the valve with the return flow direction to and from the double action cylinder, controlled with a double acting direction valve, actuated control with a reverse pump. Differential Figure 4.1 shows a single-acting cylinder, shows the rod end, ram, gland, nut, packaging gland, cylinder housing, and fluid supply head end. Cylinder, differential cylinder, as the area where the pressure applied with the piston are not equal on head end, and the full piston is available with applying pressure rod end only at the angular areas available for applying the pressure rod ends are not a factor, and what space does not take reduces the volume of oil will hold. Two general rules about differential cylinders are with an equal gallons per minute delivered to either end of the cylinder will move faster than retracting, possibly because of the reducing volume capacity. With equal pressure, either end of the cylinder can exert more force extending position, but because of the greater piston inactive, the equal pressure is applied with the both ports at the same time. The cylinder will extend because of higher resulting force on the head end. 4.2 shows a double-acting cylinder. We'll start from the bottom. Head end and then the port A supply for extending. Ram lip, cylinder housing. Port B, fluid used for retracting package gland, glad nut, ram, rod end. That's a double-acting cylinder, meaning it has two ports. Non-differential cylinder Figure 4.3 has a piston rod extending with each end that has equal thrust and speed, either the way with the provided a pressure flow with the unchanged. Non-differential cylinders are rarely used for mobile equipment. A ram-type cylinder, a ram-type cylinder is a cylinder with a cross-sectional area of the piston is more than one half of the cross-sectional area of the piston head. With many cylinders with this type of the rod piston that have equal areas. Ram-type actuating cylinder is used mainly for the push function rather than pull. Figure 4.1, page 4.1 shows a single-acting ram type. Single-acting ram applies force in one direction. Cylinders often use a hydraulic jack. In double-acting ram type cylinders, both strokes over the ram are produced pressurized fluid. Figure 4.2 shows this cylinder. 4.3 shows a non-differential cylinder, steel ring, seal, piston, shaft, fluid ports. Figure 4 shows the telescopic ram-type actuating cylinder can be single or double-acting. In this type of the cylinder, with the shear of the ram nested within telescoping assembly, except for the smallest ram. Each ram is hollow and serves as a cylinder housing for the next smaller ram. A ram assembly housing, which also provides fluid ports, although an assembly requires small space with all the rams retracted. A telescoping action of an assembly provides relatively long stroke when the rams are extended. 404 shows telescoping ram actuating type. Shows port A raised, port B lower. And then shows ram 1, ram 2, ram 3. And notice it goes in from port A up against the plunger and then into ram 1 and then ram 2. And then ram 3 is the cylinder with an exit pass to port B. Piston type cylinder, cylinder cross-sectional area head referred to the piston type cylinder with usually mainly push-pull and functions are needed. A single-acting piston type cylinder uses fluid pressure to apply force in one direction. In some designs, force gravity moves piston for the opposite direction. However, the most cylinders of the type apply with the force of the both direction. Fluid pressure provides force in one direction. Spring tension provides force in the opposite direction. Figure 4-5 shows a single-acting spring-loaded piston type cylinder. Cylinder spring is located on the rod side of the piston. Some spring-located cylinders, a spring is located on the blank side, a fluid part on the rod end cylinder. It shows the most piston type cylinders double acting, which means the fluid enters. Fluid under pressure can be applied to either side of the piston, providing movement of applying force considering direction. Figure 4-6 shows the double acting piston type cylinder. Figure 4-5 shows a single acting spring loaded piston type cylinder. Shows the air vent of the piston rod, the return spring, the piston, the seals, and fluid part. This cylinder contains one piston rod assembly operates from fluid flow in either direction. Two fluid ports on one near each end of the cylinder alternate inlet and outlet depending on the direction control valve flow directions. Unbalanced cylinder. This is an unbalanced cylinder, which means there is a difference effect of the working area on the two sides of the piston. The cylinder is normally installed so the head end of the piston carries the greater load in that the cylinder carries the greater load during the piston rod extension stroke. Alright, figure 4-6 shows a double-acting piston type cylinder, clevis, piston, steel, ring, seal, fluid ports. Figure 4 shows a balanced double-acting piston type cylinder, effectively working air on both sides of the piston, the same, exerts the same force in both directions. G, a cushion cylinder. Slow in action to prevent shock end of the piston stroke. Some actuating cylinders are constructed with a cushion device or either both end of the cylinder, but the cushion, usually a metering device built in the cylinder, restricts the flow of the outlet port, thereby slowing down the motion of the piston. Figure 4 shows the cushion actuating cylinder. 4-7 shows the cushion actuating cylinder, fluid ports A and B, check valve, metering orifice, steel ring, seal, piston. H, lockout cylinder. Lockout cylinder used for the lock of the suspension mechanism track vehicles when vehicle functions stable to platform. The cylinder also serves as a shock absorber when the vehicle is moving. Each lockout cylinder is connected to the rod arm by a control lever, which each road wheel moves up with the control lever force of the respective cylinder to compress. Hydraulic fluids is force around the piston head through the restricted port, causing the cylinder to act as a shock absorber. The hydraulic pressure applied with the inlet port with the cylinder contacting inner control valve position. Piston is forced against the spring in each cylinder. This action closes the restriction ports, blocks the mains piston into each cylinder, lock the suspension system. 4-2 construction application cylinder constructed the barrel tube of the piston of the rod with the two end caps, suitable oil sealed, bearable, usable, seamless steel tubing or cast, and their interior is finished very true and smoothly. Steel pistons is highly polished, usually hard chrome plated to resist pitting and scoring, and supported in the end cap bushing and polished surface. Cylinder ports are built with the two end caps with screws onto the tubes welded or attached by tie bolts or bolted flanges. The cylinder's barrel is cast. The head end of the cap may be integral. Mounting provisions are often made with the end caps, including flanges, stationary mounting, clevises, swing motion. Seal and wipers installed with the rod end cap. They keep the rod clean to prevent the external leakage around the rod. Other points where the shield with the end cap, the joint with the trim of the piston and barrel, but depending on how the rod is attached to the piston, seal may be needed. Internal leakage should not occur at the piston. It wastes energy and cannot stop the load of the hydraulic lock oil trap behind the piston. Figure 4.8 and page 4.6 show force and motion application cylinders. Because the fluid power system have many requirements, actuating cylinders are available in different shapes and sizes. Cylinder type actuator versatile, may be more trouble-free with the component fluid power system cylinder. Mechanical member of the unit to be actuated must be aligned correctly. Any misalignment will cause excessive wear over the piston rod, and seals. A piston rod actuating unit must stay properly adjusted. Clean the exposed end of the piston rod. In short form matter does not get into the cylinders. 4.3 maintenance. Hydraulic cylinders are compact, relatively simple. The key points to watch and seal them with the pivot of these following lists to serve the tips of maintaining cylinders. External leakage. Leakage in cylinders end cap of the leaking, tightening them. The leak still does not stop. Replace the gasket. Cylinder leaks around the piston rod. Replace the packing. Make sure the seal lips and toward the pressure oil. If the seal continues to leak, check with the paragraphs 4, 3, E through I. Internal leakage. Leakage of the piston seal inside of the cylinder can cause sluggish movement and settling under load. Piston leakage can cause warm piston seals or rings. Scored cylinder walls later may be caused by dirt and grit of the oil. Note when repairing cylinders, replace all the seals and packings before reassembly. Creeping cylinder. Creepy cylinder creep when stopped in mid-stroke. Check for internal leakage, another cause for the worn control valve. Sluggish operation. Errors in the cylinder most commonly cause sluggish action. Internal leakage of the cylinder, another cause of the action. Sluggish and start up of the system. Speeds up when the system is warm. Check for oil high velocity. See if the machine's operating manually. If the cylinder is still sluggish after these checks, test the whole circuit and the worn components. E. Loose mounting. Pivot points and mounts may be loose. The bolts and pins may need to be tightened. They may be worn out. Too much slop or float in the cylinder's mountings. Damage the piston rod seals. Periodically check all cylinders for loose mountings. F. Misalignments. Piston rods must work in line at all times. They are side loaded. Piston rods may be galled and packaged will damage, causing leak. Eventually, the piston rods may be bent or welds broken. Alright, cylinders can be used with third-class lever. A cylinder can be used a trammel plate. A double sprocket wheel makes the rotation more continuous. Cylinders can be linked up directly. Points of application of the force follow the direction of thrust. Motion transmitted in the distance point of the flame motion. Simultaneously throughout the two directions are obtained. Two pistons or fixed strokes position lead in 4 stations. Motion of movable rack is twice that of the piston. Cylinder can be used as a first-class lever. Toggle can be actuated by the cylinder. And gear sector moves perpendicular to stroke piston. That's applications of the cylinder. I wish it was a clearer picture. Lack of lubrication. Piston rod has the lubrication rod packing good seize, which could result in erratic stroke, especially single-acting cylinders. Abrasive on piston rods. When piston rod extends into the pickup of the dirt or other material with the retract that carries the grit of the cylinder, damage the rod seal. For this reason, rod wipers often use the rod end of the cylinder to clean the rod. As retract with the rubber boots also use over the other end of the cylinder. In some cases, piston rod rusting and other problems. Storing cylinders always retract with a piston rod to protect them. If you cannot retract with them, the coat will then with grease. Burrs on piston rod. Exposed piston rods can be damaged. Impact with a hard object. Smooth surface of the rod is marred, and rod seal may be damaged. And clean burrs on rod. Immediately use crosses cloth. Some rods are chrome plated to resist wear. Replace the seals after restoring the rod to surface. J. Air vents. Single-acting cylinders, except for the ram types, must have the air vent in the drive of the side of the cylinder to prevent the dirt from getting in. The filter devices may also self-cleaning. Inspect periodically to ensure they operate properly. 4.4 Hydraulic motors. Hydraulic motors convert hydraulic energy to mechanical energy. Industrial hydraulic circuit pumps and motors normally combined with the proper valving and piping to the hydraulic power transmission pump, which is mechanically linked to the primary mover, draws fluid with the reservoir, forces it to the motor, which mechanically linked to the workload, is actuated by the flow. So the motor, torque, or both are conveyed into the work. Figure 4.9 shows the basic operation of a hydraulic motor. 1. High pressure fluid of the hydraulic pump enters the motor. 2. The fluid forces the motor's movable elements into motion. 3. The motion turn rotates attached shaft. 4. The shaft mechanically linked to the workload provides rotary mechanical motion. 5. Fluid discharge here to low pressure routed back to the pump. Basic ratings of motor torque and pressure displacement. Torque pressure ratings indicate how much load the motor can handle. The displacement indicate how much flow with the required special drive and speed, with expressed for the cubic inches per revolution. Same with the pump displacement. Displacement is the amount of the oil that must be pumped into the motor turn in 1 revolution. Motor is fixed displacement. High with the variable displacement. Piston motors are in use mainly with the hydrostatic drive of the main types of motors are gear, vane, and piston. They are unidirectional reversible. Most motors designed mobile equipment are reversible. 410 shows a gear type motor with A and B, and 1 and 2 is the rotary shafts and the inlet and outlet. Gear type, figure 410 show that the gear type, both gears are driven in gears 1 is connected to the output shaft for the operation essentially reverse of the gear pump from the pump enters chamber A for the flows in either direction around the inside of the surface of the casing, forcing the gears to rotate, indicating the rotary motion is available for the work at the output shaft. 411 vane type motors, inlet casting vanes, outlets, rotor, springs, shaft. 4B vane type, figure 411, show the vane type motor flow from the pump into the inlet, forces of the rotor vanes to rotate, pass out through the outlet. Motor rotation causes the output shaft to rotate. Since no central physical force exists in the motor being rotating, something usually springs must be the initial hold of the vanes. In case contouring, however, the springs usually are not necessary in the vane type motors because of the different shaft that initially supplies central physical force to ensure the vane to casing contact. Vane motors are balanced hydraulic to prevent the rotor from side loading shaft. The shaft is supported with the 2 ball bearings. Torque is developed with the pressure differential oil from the pump force through the motor. Figure 4 shows with the pressure differential single vane past the inlet port with the trailing side of the inlet port with the vane is subject to the full system pressure of the chamber leading with the vane is subject to the much lower output lever pressure. Difference pressure exerts the force in vane with effect for the tangible rotor of the pressure of the difference of the effect for the cross. Figure vanes 3 and 9 as shown in figure 413, and the other vanes are subject to essentially of equal force of both sides. Each will develop torque as rotor returns. Figure 413 show the flow condition for the counterclockwise rotation viewed from the cover and body port, inlet and cover port with the outlet, and the reversible flow and rotation clock becomes clockwise. Figure 412 shows the pressure differential on a vane type, pressure outlet vane, full system pressure, and then force developed in the direction of the creates torque. Figure 413 shows flow condition from the pump to the rotor to vane, ring, and kidney slot. And then it shows a 1, 2, 3, 4. In vane type pump, the vanes are pushed against the cam ring with a central figure force of the pump is started up with the design motor seal wire rocker arm. Figure 414, page 410, pushes the vanes against the cam ring with the arms pivot. The pins attached to the rotor. The ends of the arms support with a 2 vane with a 90 degrees apart with a cam ring. Push of the vane into the slot. Vane B slides out with the reverse. Also happens at a motor's pressure plate functions same as the pump. Seals ride rotor and ring against it. Internal leakage of feed system pressure under vanes to hold the out against the ring with a simple operation of the pump. The cover of the pressure plate is right, but the high pressure port is covered. Piston type motors can be inline axis or bent axis types. Inline axis and piston motors. These motors for figure 415 are almost identical to pump. They're built in fixed variable displacement models several sizes. Torque developed the pressure drive with the motor. The motor pressure exerts the force end of the piston translated into shaft rotation. Shaft rotation most miles reversed any time in the reversing flow direction. Figure 414 shows rocker arm pushing vanes in the pump. Shows the rocker arm and then the pins and the direction of rotation. Oil from the pump is forced on the cylinder board of the motor, inlet port with the force of the piston. Piston shove and push against the swash plate, but it can move only by sliding along the swash plate point further away from cylinder barrel, which causes it to rotate the barrel's spline and shaft so that it must turn. Shows inlet outlet port valve plate slot, piston subassembly, swash plate, drive shaft, cylinder block bore. Alright, motor displacement depends on angle of swash plate. Figure 416, the maximum angle to displacement high is because of the piston trouble the maximum length, but the angle produced with the piston shortens the reducing displacement flow and remains constant. Motor runs faster, the torque is decreased, the torque is greater at the maximum. The displacement because of the component of the piston forces parallel the swash plate is greatest. Bent axis piston type motors, the motors are almost identical to pump. They are available in fixed and variable displacement models. Figure 417 in several sizes. Maximum swash plate angle, maximum displacement, decreased swash plate angle, partial displacement, swash plate angle, 0 displacement. Alright, variable displacement motors control mechanical pressure compensating when the motors operate similarly on inline motors with the except of the piston thrust against the drive shaft flange. Parallel component with the rush clause of the flange determine the torque is maximum, maximum displacement speed at a minimum. The design pipe motor is very heavy, bulky, particularly variable displacement motors. Even these motors on the mobile equipment is limited. Although some piston type motors are controlled with a directional control valve, they often use the combination variable displacement pump motor combination hydraulic transmission. You provide with the transfer power between the driving element, such as an electric motor driving element. Hydraulic transmission may be used with the applications such as speed reducer, variable speed drive, constant speed, constant torque. Figure 417 shows the bent axis piston motor, output shaft axis, output shaft, cylinder block axis, piston, valve plate, cylinder block. Drive and torque converter. Some advantage of hydraulic transmission has over mechanical transmission is that it's quick, easy speed adjustment, wide range power source operating in constant, most efficient speed, rapid, smooth acceleration, deceleration, control over maximum torque and power, cushion effect with a reduced shock load, smooth reversal of motion. Chapter 5, Valves.